Thank you for joining in with us today. My name is Kristen. I'm part of the CLF Alberta team, and there's a few of us on board today. You'll see us by our backgrounds. You'll see in the scrolling slides, we are at clfalberta.com, so you can see all of our previous events, or you can see, what's upcoming next. So please check out our website, subscribe to our mailing list, and you can keep in the know about all the carbon events coming up. And also, of course, the carbonleadershipforum.org is a great website to go to for any of your carbon resources and case studies and lots of information resources are available there, everything from policy to case studies. So I would highly recommend checking that out. And today we are joined by Stephanie from DIALOG. So I will let us get right to it just in the thinking about time. So Stephanie, please take it away.
Thank you. I'm just going to share my screen now.
Oh, I think you're muted. Oh no, sorry, it's just me. I gotta stop sharing. I'll let you share. Sorry about that.
Okay, and then just want to do that. I just want to make sure you guys all right, there we go. Okay, hi everyone. My name is Stephanie Dalo, and I am a sustainability specialist and licensed professional engineer at DIALOG. My responsibilities include working with project owners to determine the project's sustainability strategy and coordinating and facilitating communication between design teams to keep projects on track towards meeting their sustainability goals. I also conduct full building lifecycle assessments to determine the carbon impact and offer suggestions to help project teams find low carbon design solutions.
I'm Stephanie Fargas, an associate and specification writer out of the Calgary studio. I've been with DIALOG for over 10 years, specializing in high performance buildings and material transparency. And I'm currently working on initiatives within DIALOG and with external clients to advocate sustainable procurement methodologies. For AIBC members, please fill in the sign-in sheet, which will be provided. If you can put in your full name, email address, and AIBC license number, and DIALOG will submit this on your behalf within the next 10 business days. You do not need to self-report. For other registered architects and credential holders, the AIBC credit is accepted by the AAA in the OA, for example. If you wish to receive a certificate, please leave your full name and email address, and you must self-report. And now this course is aimed to provide familiarity with the overall guiding principles of circular design. The goal will be for you guys to be able to better understand these concepts and accompanying strategies so you can make more informed and critical decisions making in your day-to-day work and your respective discipline. And if we can launch the first poll question. Great, thanks. So it looks like there's a wide variety of responses. So we're just going to go into the agenda. So today we're going to discuss circular design overview, as well as environmental product declarations and methodologies for product selection, and then go on to design for disassembly. Next slide. Next. So with a conventional method in building design, it follows a linear model, which is an open loop system where raw materials from the biological and technical nutrients are extracted and then manufactured into a product to eventually be disposed of afterwards. By applying circular design principles, it transforms the model into a closed loop or regenerative system. In this closed loop, materials and components in buildings are recycled, reused, or reclaimed. This diagram makes a distinction between the biological or natural materials and the technical or man-made materials, and it describes a series of loops and cascades of materials between stakeholders in this resource cycle. Both biological and technical cycles together represent the core elements of a circular economy. The biological cycle consists of materials that after end of use can be biodegradable without polluting nature, such as cross-laminated timber. The technical cycle consists of materials that are after end use can be separated and reused into new generations of industrial products without loss of quality. An example of this would be structural steel. Circularity aims to intentionally design systems that separate these two kinds of materials and cycles them into new generations of industrial products without degrading their quality. You'll notice in the diagram that there are shorter and shorter loops. These are meant to describe the concept of upcycling, which aims to shorten the cycles between material reuse. The shorter the cycle, the more energy is retained. And in this diagram, it identifies the different design service life of various layers or components within a building. A design service life is a service life specified by the designer in accordance with the expectation of the owner of the building and the extent of anticipated maintenance, replacement, and repair. Depending on a project typology, the design service life of structural elements can sometimes be only 5 to 10 years. Through circular design, the intent is for the structure to be a minimum 50 to 100 years, thus prioritizing the long-term durability of elements to achieve an extended design service life. Now I will pass it on to Stephanie Dalo.
Thank you. So a strategy that can be implemented to achieve circularity in your projects is designing for disassembly. Yeah, you can think of it kind of like getting the most bang for your buck. When you design for disassembly, it allows for systematic and selective disassembly at the end of life, making deconstruction more feasible. This in turn can allow for salvaging of materials and therefore diverting construction and demolition waste from waste streams. This also makes it so that the carbon was originally emitted through the extraction, processing, and manufacturing phases remains stored in the material or building components that can be reused. When designing for circularity, it is important to source materials and products that have lower environmental impacts. An environmental product declaration, or EPD, allows the project team to better understand and measure the material's global warming potential and its contribution towards the environmental impact categories. Typically, designers are mainly concerned with ordering products that have EPDs so that they can gain lead points. However, EPDs can also offer both architecture firms and the clients a benchmark to define the environmental performance of their portfolio, and these portfolios can go on to be shown to future stakeholders. If EPDs are used more often, it will help provide more transparency in building product markets and elevate the awareness of the environmental impact of products. Stephanie will go into EPDs in more detail later on in the presentation. Another strategy to consider is material monitoring. Some firms are looking into this concept by defining something called material passports, which aim to connect the physical materials with the digital data. Effective recovery and reuse of components, products, or materials in buildings requires that the right information is easily accessible. Material passports act as sets of data describing defined characteristics of materials in products that give them value for recovery and reuse. For example, technology such as radio frequency identification chips, or RFID chips, as shown on the left there, can be embedded into a product which connects to a database that hosts information about the product's material, embodied energy properties, and assembly and disassembly instructions and location. There are examples of this kind of technology being used today. Trumco and the Hong Kong Housing Authority have been using RFID chips for better tracking of their products. Trumco is using RFID chips in their roofing to scan to find out product info and if there is an EPD, maintenance, or etc. on the roof. And the Hong Kong Housing Authority is also using RFID chips in their building elements to enable real-time visibility of precast building components that are connected to the BIM and transportation logistics. On the other hand, as shown on the right there, there's the SuperU Studios Harvest Map, which is an open source platform that tracks leftover industrial and deconstruction materials. The idea is that these materials enter a platform that acts as a material bank. It has been used in the Netherlands and in Italy, and there is a growing interest in North America about this as well. We're not going to focus too much on material passports today, but the idea is that this approach can better enable disassembly strategies and the use of EPDs. And the idea also extends past involving disassembly and material screening information to suggest that we can share materials and products across projects. This concept has been referred to as buildings as material banks, since it suggests that buildings can essentially lease materials and trade them between projects. This is a case study that was carried out by GXN Innovation. So circular design is a relatively new concept in the architecture, engineering, and construction industry, although some firms such as GXN have been developing its applications throughout design phases for years. GXN has mapped out how they plan to integrate circularity in the design process at 3 phases: before, during, and after design. So before design commences, the company becomes concerned with realizing the potentials of circular strategies by conducting analysis, creating visioning or goals, and engaging the project team and other stakeholders with high ambitions for the project. During the design phase, the circular strategies that defined in the pre-design phase are transferred into the value propositions and an agenda is set. This is where design for disassembly, material passports, and the use of EPDs come into play. Once the design is completed, there are a few strategies that can help a building maintain its circularity. We can perform post-occupancy evaluations and monitoring information such as the data that is in the material passports, since a project can be thought of as an adaptable material bank that can benefit users across generations. This study by GXN is just a brief example of how circular design thinking can be implemented through the different design phases. And now I'm going to hand it back over to Stephanie Fargas so she can talk to you more about environmental product declarations.
Thanks. So an environmental product declaration, EPD, with a supporting product category, a PCR, and life cycle assessment contain information that can be utilized to determine whether a product can be incorporated into the project to reduce the environmental impact categories. EPDs are classified into 2 main categories of industry-wide generic or product-specific with a type 3, with type 3 being third-party certified with verification. And now this diagram illustrates the process involved with the creation of an EPD, which I will go over. Before an EPD can be created, a product category rule is developed to identify information on the product, define the scope, impact categories, and measurement methods. PCR can be created through assistance and guidance from industry leaders such as industry associations, government, and reference standard committees. PCRs are meant to be objective, defining documents that serve as the framework for conducting a life cycle assessment, which that data can be used to inform an environmental product declaration. PCRs can promote fairness by ensuring that all the products of the same type are measured within the same metrics. PCRs are often initiated by an industry request from a manufacturer wanting a product-specific EPD. Some examples of program operators are ASTM International, ICIC Evaluation Services, Institute of Environmental Research and Education, the NSF International, SCS Global Services, and UL Environment. An LCA documents a product's life cycle in either a cradle to gate scope, so the A1 to the A3 category, stating or starting with the resource extraction to the product leaving the factory gate before it is transported to the consumer. Another method is cradle to gate, grave, A1 to the C4 category, which starts with a resource extraction to the product ending either in landfill or a recycling plant. An LCA utilizes ISO 14040 and 14044, which define the goal and scope of an LCA, what the functional units being studied, what the life cycle inventory or LCI is, which is a list of material and energy inputs and any releases into the environment. The life cycle impact assessment through the review of an LCI identifies and measures the impact category. And the life cycle interpretation, including a review of information and limitations of the data. The LCA are conducted to determine the environmental impact of a product, or it can be done for a whole building, has on its environment based off of these 6 environmental impact categories. Global warming potential, also referred to as the greenhouse gases or embodied carbon, the depletion of the stratospheric ozone layer, acidification of land and water resources, eutrophication, which is a measure of a product's potential contribution to nutrient runoff, which can damage aquatic ecosystems, the formation of the tropospheric ozone, depletion of non-renewable energy sources. If a whole building LCA is conducted, there are various tools in the industry that can be used, such as Athena Impact Estimator, Tally, which is merged with EC3, and One-Click LCA. These tools utilize different life cycle inventory data from sources such as Ecovent, US Life Cycle Inventory, and Gabi. Here is an example of an EPD. An EPD will include a summary of the product's impact through the various impact categories. It's important to know when reviewing an EPD to have it current and valid, so within 5 years, and that it's not expired, as well that it follows all the stated ISO and EN standards. So if we can launch a poll question.
Sorry, working on it. For some reason, it's taking me to the old one. Oh, got it. Sorry. There we go.
Okay, I will end the poll, and that's great to know. Most of you got the answer correct. And so the answer to that one is the A1 to the A3 category. So it's important to keep in mind, based off of the current marketplace, there are opportunities as well as limitations with EPDs. I'll go over some of the limitations. Right now, PCRs may not necessarily match. For example, an EPD from Europe will not necessarily have the same PCR of a manufacturer within North America. As well, there currently is no standardized approach format of an EPD, because each program operator has developed their own format. And EPDs currently are not required to include any information on toxicity. However, some manufacturers that advocate for a holistic approach to sustainability, such as Forbo, have included in their product-specific EPD information on the impacts to human health and the ecotoxicity. Some of the opportunities right now is the design and construction industry can take on the disruptor role to the status quo and facilitate market transformation. Consultants can utilize LCA and material transparency to benchmark their design portfolio, also assist with elevating the knowledge of staff for awareness of a product's environmental impact. In addition, clients can utilize LCAs to benchmark the sustainability, performance, and carbon footprint across their building portfolio and identify areas of improvement. So the government of Luxembourg, through their Ministry of the Economy, has initiated its Circularity Data Set Standardization Initiative, which aims at establishing an official standard for communicating data on the circular economy properties of products in consultation with Positive Impact and various other companies from 12 European countries, as well as the United States. A product circularity data sheet, PCDS, will allow to provide a common language about a product circularity, enable product transparency, provide the same data to all the customer or end user, provide data independently of the future use, and improve the next generation of product design. The PCDS will include product and company identification, product composition, design for better use, design for disassembly, and design for reuse. All of this will be provided in a standardized format. And now I will pass it on to Stephanie Dalo.
So designing for disassembly is a holistic design approach where the intention is to make any given product easy to disassemble into its individual components. The approach is a cornerstone of the circular economy because it allows the different components to fit into a closed material cycle where they can be reused, reassembled, recycled, or repurposed into new products of similar or higher quality. A useful resource when designing for disassembly is the ISO 28887 standard, which includes information on adaptability principles such as versatility, convertibility, and expandability, as well as the disassembly principles, which includes requirements on ease of access to components and services, avoidance of unnecessary treatment and finishes, supporting reuse or circular economy business models, simplicity, standardization, and safety of disassembly. 5 principles for designing for disassembly include choosing reservice connections that tolerate repeated assembly and disassembly, choosing materials with properties that can ensure they can be reused, designing the building with whole lifetime of the building in mind, designing a simple building that fits into a larger context system, as well as creating a plan for construction, also designing the building for deconstruction. Since the architecture, engineering, and construction industry has gotten a better handle at reducing operational energy, the focus is broadening to reducing embodied carbon. To do this, we are required to complete life cycle assessments, and depending on the client's ask or certification standards we are following, we will be required to meet specific reduction. Upfront carbon outweighs operational carbon, but if buildings begin to reuse salvage materials from previous structures, we can significantly reduce the embodied carbon associated with the building's product stage or cradle to gate stage we discussed, which is A1 to A3. Now, the more likely situation will be that we use virgin materials, or maybe that some materials are even recycled. But if project teams begin to plan for end of life and design for disassembly, this will mean that a cradle to cradle approach is taken, which can be an innovative strategy for reducing embodied carbon of the structure you are designing. So that means accounting for stage D, because when you do that through circular design or design for disassembly, it may result in negative values for impacts, which can reduce the overall impact of the building. By not targeting or accounting for these activities in a life cycle assessment, projects are depriving themselves of the credits for recycling, reuse, or recovery. Depending on what material or building structure system is being used, there are so many different types of connections that can be considered. To design connections that tolerate repeated assembly and disassembly, we would want to make sure that the connections are reversible and accessible, use mechanical joints that don't damage material, and use dissolvable binders where possible. Piercing nails through structures and materials to make connections is commonly found in the construction industry. But the unfortunate downside to this is that the nails damage the materials and cannot be retrofitted to other uses. Instead, it is better practice to practice using screws, nuts, and bolts because it makes the structure easier to disassemble and salvage materials for reuse. When considering fasteners, they come in all shapes and sizes to allow maximum freedom when assembling things together. But this, however, can become problematic when considering second use of the same material. By using a similar fastener, throughout the building construction, there will be less trouble identifying different types of fasteners that are used, and fewer tools would be needed for deconstruction. Also, it is better to use dissolvable binders rather than glue and sealants when considering the disassembly. Glue and sealants do not consider the next life of the material and leave residues and sometimes tear the material when separating material elements. By using dissolvable binders, the strength of the adhesive is lost when exposed to water, temperature, and etc. without agitation. Can we, oh, actually, never mind. I think we're gonna put a question later on. Here is the tectonic options for disassembling connections using mechanical fasteners. So here we can see separable joints using nuts and bolts to connect slab to wall and walls to wall, and separable joints using nuts and bolts and lime and mortar to connect slabs to beam or slabs to slab. In this example, we see a column to beam connection detail, which proposes using mandrels. This is an example of how we can make connections reversible, accessible, and easy to disassemble and assemble.
Yeah, so I think now we can launch the poll question.
Mhm.
Okay, great. Yeah, all of you have gotten the question right.
Yeah, very good. Okay. This last example of connections is showing dissolvable binding agents used to cast metal stirrups into the panels for attachment rather than welded or casted metal channels. So this is another example of an accessible connection that uses reversible bolt connections. So it seems like you guys have caught this, understand this part of the principles of design for disassembly. So when considering materials, we want to choose high quality, durable materials that are pure and easily recyclable. Facade bricks can be assembled in modular chunks where the bricks are connected with lime mortar to allow separation. You can use durable concrete that doesn't require paint for walls and floors to decrease the need for maintenance. You can design windows that can be disassembled since they will need to be changed during the building life. And you can choose solar shading that uses mechanical instead of welded connections. So it is better to use lime mortar instead of Portland cement because the latter is impossible to disassemble. It will only leave rubble when it's destroyed, as well as the brick will break before the cement. Lime mortar is much more flexible and permeable, and it can be removed by hydroblasting or by beating it with a hammer. With respect to service line, we want to design for flexible elements that are easier to change over the short-term, short life systems, either better said to say easier changing of short life systems and adaptable life cycle layers. So facade cladding can be attached to the building using to allow easy renovation. So for example, using unitized curtain walls. The floor surfaces can be divided into wear zones with areas of high traffic that can be replaced easily and independently. And design partition walls that can be easily moved to allow for interior flexibility. So for example, using demountable partitions. And you can install ventilation and cables in the floors to allow for interior flexibility. And here's a snapshot of 3 projects in Denmark, and one of them is in Switzerland, where the percentage of standardized elements that were used in the design and construction of the buildings are being shown. And you can see there's a high portion of standardized elements. Standardized parts make it easier for contractors to disassemble structures while using efficient and repetitive techniques, and can also allow for easier transportation, storage, and reuse. This approach supports aspects of simplicity, adaptability, and further reuse. We want to talk about this, kind of conclude with this example of a people's pavilion that was constructed using only borrowed materials from various partners. This necessitated special care for dimensions and connections, and the attachment strategy required straps to assemble the timber elements to the concrete piles. Dimensioning the project to material size was done in order to avoid cutting or damaging materials. And the steel mat and simple fastening system was chosen for the facade assembly. This is a snapshot of the complete inventory of materials that were used in the project, and materials returned to the partner. Actually, I have a double of this because I wanted to kind of expand it here so you can see it twice. And then, so this is how it all turned out. This was a 100% circular building where no building materials were lost in construction. The People's Pavilion won, this was actually designed as part of the Dutch Design Week, and it won the Frame Awards in the category Sustainable Design, Habitat category, and the ARC 18 Innovation Award. So 100% of the materials, the concrete and wooden beams, the lighting, the facade elements, glass roof, recycled plastic, cladding, and even the pavilion's glass roof were all returned completely unharmed to the owners following the Dutch Design Week. Only the cladding that you see, the tiles, were actually given to the attendees at the end, which is pretty nice. So we wanted to just include this for your future references of the resources that are helpful when designing for disassembly. And we also wanted to wrap up with this nice quote from William, the co-author of Cradle to Cradle. By generating perpetual value in the making and remaking of things, we are putting the back into resources and improving the quality of life. So thank you for attending, and we'll take any questions now.
Just quickly, did you want me to launch that last poll?
There was one more question.
Yeah, one more.
Thank you.
Yeah, brownie points. Great.
Mhm.
Okay, I'll call it.
Yeah, it's good. So we see some people chose aluminum composite panels. I think it's not as simple as unitized curtain walls or precast concrete panels because of the whole assembly can make that, I think, more complicated to recover or reuse that material. And same with brick, depending on the mortar that's used to connect it, it can make it complicated to salvage that material. Okay.
All right.
Thank
you,
you,
Stephanie and Stephanie. Any questions?
What, should I stop sharing or should I leave it up?
Up to you. Yeah, I mean, we can reference things in a bit maybe if needed, but
okay.
We'll see if any questions were on. We're doing very well for time, so great job.
Oh, thanks.
No questions yet. People need to ruminate on this maybe a bit.
Mm-hmm.
Oh, here we go. Judith is asking if there's any precedent projects in Canada. Great question.
Yeah, that's a really good question. And in fact, that's an area that we even want to investigate more. All I really found as an example that I could study was a mountain equipment co-op that was constructed or designed for disassembly in Montreal. So there aren't a whole lot of examples, it seems, or maybe they're not publicized as much. So we need to look into that more. And I think if we're not finding them, we need to just go for it and start trying and start creating those examples that others can reference as case studies for future projects.
I love that. Be the change. Be the
Yes,
change.
exactly. It's a
Oh,
great
there's
question.
another example maybe from Brenda.
Oh, yeah.
A project at UBC, CK
Oh, do we
Choi.
know which one that was, Brenda? Oh, oh, CK Choi. Oh, okay. It's good to know. I will look into that one.
Definitely good to always have the case study to go back to and review and
Mhm,
see where people succeeded and maybe some lessons learned as well.
mhm. Definitely more examples exist in the UK, which is why, it would be good to maybe pull some people from, or not just the UK, but Europe that have this experience, and maybe we can bring these best practices to our to North America.
Great. Ignacio has his hand up. Go ahead.
Yeah, I thought it would be better to, and you asked the question. This is first a great presentation, very worthwhile in terms of looking at, what can we do as a design community to go forward and look at things differently. And the question I had was more specifically related to standards. My previous experience, my previous life has been in a precast concrete world, where we typically design everything to be demountable, but yet there is no standards to really regulate or put rules around it. But I see a huge potential of a lot of projects that have been built that you can go back and demount. And we know that concrete has its resiliency and durability concept, which is actually designed for over 100 years. So if you were to demount it, you can easily reuse it. Examples are arenas. The bleachers typically are precast concrete that could be demounted and used in a different arena after its life. Not to go very far, I can give you the first example, a saddle dome. That's a perfect example of that. It has bleachers that have been precast, and it wouldn't be any difficult to demount and reuse it somewhere else. So the question is, why can't we look at this closer? Why are people looking at it closely in terms of, what's the gap right now in the standard side that prevents us to do that?
Stephanie, do you want to take this one?
I was going to say, do you want to take that one? Because I think you should elaborate on your experience working with Metro Vancouver and their initiative for the material bank.
Yes, I think really the reason why it's not being done as much is maybe this is maybe, based on my experience of what I've been seeing, is that it just really requires thinking beyond the building life cycle, and not enough thought is really just going there. I think it's being driven by this need to reduce embodied carbon, which is, now that we're calculating, we're seeing the stages, we're noticing where is the low-hanging fruit. And that's what Stephanie and I have been really focusing on is, well, we need to start planning for beyond the building life cycle then, instead of, and it really, I know this is kind of cheesy, but it's really out of the box thinking. Literally think out of the box of your building and where this material is going to go at the end. And I think it's just a matter of, it's a bit of a systemic problem, and it's a matter of when you have to pull a design team together, they're already just very focused on designing the project for now. And you need to be proactive, you need to be thinking long-term. And I think finally, we're starting to really catch on to how important that is. So I don't think it's impossible. I really think it's easy for us to do. And it's just changing our behavior, changing our approach, changing the culture of the AEC industry so that we're doing that.
Yeah, and that ISO standard that you referenced in your slide, that is a new publication. So hopefully with that becoming more mainstream, some engineers are going to start applying those into their design to be a bit more meaningful with the design of their structures.
Hope that answered this to some degree.
Yeah, no, it's such a low-hanging fruit, but it's amazing that nobody has actually looked at this. But yeah, it's maybe call to action. Any listeners out there, this is low-hanging fruit.
Well, I think, sorry, one more thing I should say on that. Yes, it should be standardized, but with anything that you're trying to make a case for it, you kind of show the cost benefit analysis. And maybe right now we're getting a lot of asks to do a life cycle assessment, but there's also the life cycle cost assessment. And if we maybe show the return on that, if they think about selling that product in the future, then they'll see the value in that. So it just maybe requires a bit of extra effort to show them why they should be making that decision.
Well, economy can be a big motivator. So I would certainly say that could be the big catalyst.
Mm-hmm.
Stephanie, are you able to discuss the work that you're doing at the Sustainable Design Leaders group?
Sure, I should, I'll mention, so Building Green has the Sustainable Design Leaders Network, and Stephanie and I saw another dialoguer here, Andre, hi, that is also a part of that network. And so that network has, many people that create their own working groups, and I created a working group with a couple of other women from the States that it's on material flows. And so right now what we're identifying is the current practice. We're seeing where do companies and other advocates and whoever exists that are advocating for material recovery and reusing those salvage materials into buildings. What are companies or stations that recover that material so that it can be recovered and sold back. So we're building this map, and the only thing is it's mostly American companies. We have some in BC, some in Toronto that are being shown, but it would be nice to build something out for all of Canada as well, I think. And then as we go through this process, we're not only we're seeing that exists, but there are still some challenges in having this discussion with other kind of key players in the space that still trying to recover that material when you're not really planning for it. It requires, like that last photo I accidentally showed twice, but it had a lot of impact, so I don't regret it, with seeing how organized a site can be when you're designing for disassembly. You need to be thinking about that when you are thinking about demolishing or deconstructing your building, because you need a proper laydown area to separate those materials. And when you don't have a laydown area, when you don't have space for that material to go, like for example, a warehouse, it makes it easier for that material to just either go to a landfill or be recycled and not really thinking about holding it until it's recovered. So this working group with the Sustainable Design Leaders, we're talking about material recovery now, but on a bigger kind of scope, we're also trying to advocate for designing for disassembly and circular design, because in it all works together, and thinking about how we plan for that material to be recovered. Because one last thing I'll say is, when you think about the buyers of this reused material and the sellers of the material, they each have their unique problems. The sellers have, like what I said, it's hard they don't have the consistency of providing the same kind of quality of material at the same type of consistently available. And then the buyers feel of that same challenge with not knowing the consistency of if that material is going to be available or not. So there's the commitment from the sellers and then the uncertainty of the buyers in that material. So all of these things are things we need to start addressing. And I think everybody has their part in addressing them in some way or another, so that we could start advancing the circular built environment.
Great. I love that answer. It was perfect. And just to point you to the chat, everybody, there's some great questions happening there about air pollution being included in the LCAs. So Stephanie's written about that. I don't know if you want to talk about that, Stephanie. And then also a fun fact about the city of Edmonton using a bridge. That's a great fun fact for Edmonton. Way to go, Edmonton. But maybe I'll let you talk about air pollution, Stephanie.
Yeah, so the 6 that I had mentioned are the ones that are typically defined in the ISO or the EN standards, but there are options to add additional impact categories if a manufacturer is interested in exploring additional, I guess, negatives that a product may have. It's also important to know that even if you reduce the GWP of a product, it doesn't necessarily make all the impact categories improve. So I thought that was a bit of an interesting thing, because when Stephanie and I were looking into some of the different EPs, we noticed that there's not really a metric to be able to apply a percentage of if you reduce it by 20%, everything improves. So it's important to look at it holistically.
Mm-hmm. But that is, when we think about air quality, that's another reason why the actual act of deconstruction is better, because when you have, demolition, whether it's, a large, heavy equipment tearing it down, or a wrecking ball or whatever, all these dust particles are being, let out into the atmosphere, and that can be very disruptive. That can be harmful to the ecosystem. So it's not just about materials that we're using that have that improve the air quality, but the actual act of deconstruction versus demolition being better for air quality.
Ripple effect.
Yeah, exactly.
Any other questions? Those are great discussions. You've got time. It's very exciting.
Anything, any type of question, even if it's more of a discussion, we're happy to have it.
Yeah, how many projects would you say right now are focusing on that you have on the go, or a percentage or anything like that? Any kind of information about the trends about circular design projects?
I think it's safe to say that Stephanie and I are on a few jobs where it's an institutional client where they intend to own the building for at least 100 years. Those are the clients that even before this is becoming mainstream, they were asking us to apply these principles, just not knowing that this was actual like circular design. And also BOMA recently with its members published like a call of action for all their members to start advocating that their consultants are to use circular design within their portfolio of the BOMA members. So I think that's quite a significant shift in the marketplace, as well as different levels of government, like federal and provincial, are starting to write this as their environmental social goals that they're achieving. Or if they're a B Corp corporation, they're also starting to identify these to different levels as well.
And really the way we think of it is that, clients just have this general goal of saying we want to reduce carbon, right? Or reduce embodied carbon. And we are thinking of it as this is a strategy that they might not quite know exists. And we can do more to try to encourage it, just implement these principles that we talked about previously during the presentation. So I think it does kind of fall back on us as consultants to kind of bring this to their attention as well.
That makes sense. Yeah, definitely. You can't change what you don't know. I did have one more question if no one else has in chats. I know I'm used to dealing with like LEED and the LCAs with there and like thresholds, and you have to meet this to show this. What is there thresholds for circular design? Do you guys just deal in, like, I liked your pictures there with the percentage of the building that was, reused or whatever, but is there a go-to that you guys like to meet, or you're just hoping for any percentage or any information on that?
We both have been having conversations with consulting firms in Europe, and because they're years ahead of us, especially in London, because it's mandated, and they're struggling to try and find benchmarks because there's not enough published data within the LCA to account for the D stage. So it's an ongoing conversation that we're all having of what's the best practice to start tracking this information or using as a baseline.
I am kind of wondering if maybe we just need to also, like, it's one of those things of just somebody start doing it, but what if these like frameworks like the zero carbon certification and also LEED as an innovation and design credit, you include design for disassembly, and it's really the benchmark at this stage might just be that by planning for the recovery of that material, you're just showing the amount of carbon you're saving, carbon emissions you're saving. So maybe the benchmark is still about embodied carbon, but then we also have incentives and supports and guidance for design teams on how they actually design for disassembly. Because I will say that the challenge too with owners or whoever, they're just like, well, how do we know how this is going to be reused? And I don't think we need to think as far as how it's going to be reused, but at least giving the opportunity for it to be reused. And then that can fall on someone else and what they want to do with it. Mhm.
That's great. All right, I guess last call. And then just a reminder, I'll put the email in here. If you would like to report your hours, please send us your registration number so that we can report it. And sorry, I'm just triple checking the email. Okay. So yeah, if you can put your registration number with that to that email, I'll make sure you get on that list and it gets reported. As Stephanie mentioned, you can't self-report, so you need to send in your number to us and we cross-reference it with the people registered for the presentation today. Okay, thank you, Stephanie and Stephanie. Last round. For CLF Alberta news, we'll just be going on a winter break here, so we're just getting reset for new year and new presentations. So you'll see us again in 2022, but we'll try to keep active on LinkedIn and all those lovely things. But yeah, keep an eye out on LinkedIn and the website, and that'll be the best place to get all the future carbon information. But yeah, once again, just a huge thank you to Stephanie and Stephanie. Thank you so much for sharing your knowledge and your time.
Thank you.
Thanks for having us.
Yeah, thank you so much.
Thank you.
Bye, everyone.
Everybody. Yeah.
Bye.
Bye.